In the last few examples, I've been saying that we're using Booleans to do stuff that's more quote unquote real. Well, scratch that. This one's going to be a little bit silly, but I think it's going to be sort of fun. We've seen Booleans mostly at this point in if statements. We know I can do something like if score is less than 10, do something. And the thing inside the parentheses of the if statement is actually a Boolean. Well, what you might not have known is that Booleans aren't just specific to if statements. There's one other control structure that we've seen that actually does use Booleans in a very similar way, which is the while loop. I can type something like while lives is greater than 0. And the thing inside the parentheses of a while loop is actually also a Boolean. So what we're going to do now is we're going to do a little program that's going to actually use Booleans in a very similar way to how we've been doing. But instead of if statements, we're going to be doing things repeatedly. So we're going to be looping in some way. Maybe that's going to be using a while loop. Maybe that's going to be using a for loop. But we'll see what that's going to look like in a second. So hopefully you should have downloaded this FrogSimulation code either from what's linked below or on Schoology. It is on Schoology in our Unit 1 folder, kind of towards the bottom. I think it's right above or right below where the paycheck PDF is in the Unit 1 folder on Schoology. Once you have this downloaded, let's actually talk about what this problem is that we are trying to solve. Okay, so a little bit weird, but here's what we've got in this problem. We have this little frog. Oh my God, look how cute. He's so cute. And the frog is actually attempting to hop kind of along this line to what we're going to call a goal position or a goal distance at the end. So at the very end of our number line here, we're going to call this the goal distance. One of the things you have to know about this, though, is that the frog actually has a maximum number of hops that it can move to be able to do this. So at some point, there's kind of he can take max hops to be able to move across the number line. The other thing to know is that the frog can't actually control how much it hops all that well. So each time the frog hops, we don't actually know how far it's going to go. In fact, the frog hopping has been kind of decided for us in a method that we're going to use to be able to do this called hop distance. So we're going to end up calling a method that looks sort of like this. So this frog will be repeatedly attempting to hop until one of the things are true. Either it meets the goal distance over here, yay, and then it's successful. The frog runs out of hops, so maybe it kind of gets to here and then it reaches max hops, number of hops, and then we're done. Or weirdly, sometimes the frog can actually hop backwards. He's a little uncoordinated. And when the frog hops backwards, we're going to say that that is just an automatic failure if he goes kind of before the point where he started. So we could hop, kind of go back, go forward a little bit and still be okay. But if I ever kind of make it back to before the starting point, we're going to say that that is a fail. So we're about to write a method that's going to be called simulate. This method will simulate the frog trying to kind of hop along this number line. We have to be worried about these kind of three conditions. When does this method end? Either when the frog reaches the goal distance, when the frog runs out of hops, or if the frog hops before its starting point. What are the things that we're going to have to keep track of while we're doing this? Well, we probably need to know where the frog is along the number line, so like the frog's position or its distance. Don't we probably also need to know how many times it's hopped so we can make sure it hasn't run out? All right, let's see what this is going to look like. So I'm going to close out of this and let's open up this class called FrogSimulation. And you'll notice that in a way, this looks kind of similar to our paycheck example. We're given some class, we're actually given what the private instance variables are, and we're given the shells of the methods. And all we actually have to do is write what goes inside of this method. So to start, we're going to write a method called simulate. And this simulate method is going to do exactly as I described before. It's going to simulate the frog attempting to hop less than max hops times to make this goal distance. So what did we just say we need to keep track of? Don't I need to know where the frog's position is? So let's do int pause equals 0. And I need to know how many hops they've taken. So int hops equals 0. Now that I know what I need to keep track of, let's think for a second. I know I'm doing something repeatedly in this problem, which is that the frog is hopping over and over again. Do I necessarily know how many times I want that to happen? I actually don't. Maybe kind of max hops, but it might not actually get up to max hops. So I think I need some sort of while loop here, right? We use a while loop when we know we want to repeat, but we don't know how many times. When am I done hopping? Well, there's a couple of different conditions, but I'm going to do it like this. While my position is less than my goal distance, I'm going to keep trying to hop. Once my position reaches my goal distance, then I'm actually good to go. All right, what should happen in here is that I should do one hop. Now, the question is, what should happen when I hop? Well, probably both of these variables should be updated. But how much does my position change by? I actually mentioned when we were going over the problem that there's a method that I'm not going to actually show you what's in there because it's not really relevant, but there's a method down here called hop distance. This hop distance method actually tells us each time we hop how far we go. If you look in here, there actually is some kind of randomness involved in that about how much gets moved every time I hop. Like I said, frog's not very coordinated, so can't exactly hop the same amount every time. Sometimes he'll go backwards. It's a little crazy. So this hop distance method, when I call this basically makes the frog hop and tells me how far it went. So shouldn't first my position should actually increase by that hop distance. Now, why was I able to just call hop distance? Well, what class am I in? I'm in the FrogSimulation class, and that's where I'm writing the simulate method. You know what else is in the FrogSimulation class is actually this hop distance method. When I'm using a method in the same class that I'm writing in, I can just use it. I don't need to do instance.method or anything fancy like that. I just use the method. So my position has increased or decreased if hop distance is negative. And shouldn't my hops also go up by 1? So let's do hops plus plus. Now, we know that I'm looping while my position is less than the goal distance. So hypothetically, after this while loop ends, I should have met my goal. But what could happen on the way to meeting my goal? Couldn't I actually fail to meet the goal? And there were 2 reasons why I might do that. One is if I don't actually make the goal distance in time, if I run out of hops. So let's do if hops is greater than max hops. Aren't we going to return false because I actually did not meet the goal distance? And let's do another one. What's the other condition that would cause me to not make the goal distance? Well, if I accidentally went before position 0. So let's do if pause is less than 0, I'm going to return false. And I think in every other case here, I'm going to return true because that would mean that I went through the while loop, I didn't return false, which means if I get all the way outside, I did reach the goal distance, so let's return true. Great, we can now successfully simulate the frog trying to meet its goal distance. Let's write one more method, and this method is going to be called run simulations. Based on the name of this method, what is this going to do? It's actually going to run a bunch of simulations over and over again. And let me tell you actually what it's supposed to return, because it looks like it's returning a double here. The run simulations method is supposed to run exactly num simulations, and it will return the proportion of the simulations where the frog successfully meets the goal distance. That is, let's say num was 5, so I run simulate 5 times, and the frog reaches the goal distance twice. This method would give me 0.4, because 2 out of 5 is 0.4. So let's do this. To be able to do this, I'm going to ask the same question I asked when we were doing the simulate method, which is, what do I need to know or what information do I need to track? I'm trying to return the proportion of the simulations that were successful. So what do I need to be able to do that is, don't I need to know how many were successful and how many overall? Well, how many overall is given to me by num, but how many were successful I think I need to track. So let's do int success equals 0. Then Same as the last one, I'm doing something over and over again in this method, right? What's the thing I'm doing over and over again is running one simulation. Do I know exactly how many simulations I want to run? I do. It's actually this parameter here. When I'm repeating something and I know exactly how many times I want to repeat it, what am I going to do? I'm going to do a for loop. So for, you will have to know how to type out all of the parts of a for loop on your test. So let's practice here. Int I equals 0. I is less than num. I plus plus. Now let's run one simulation. What does the simulate method return? Returns a boolean. So let's save that in a variable. Let's do boolean made it, as in I made it to the goal, equals simulate. Am I allowed to just call simulate? Yeah, it's in the same class that I'm currently typing in right now. Now, if I made it, and I could put equals equals true here, but I don't have to, what should happen is success should go up. So I'm going to do success plus plus. At the very end of this, now I've simulated num simulations. How do I actually return the proportion? Well, isn't it just the number of successes divided by kind of the overall number of simulations? So let's return, and I believe it's success divided by num. Now there's one little caveat here. What type is success? Success is an int. What type is num? Num is also an int. When I do an int divided by an int in this class, what do I get back? Is an int. So if I have 2 divided by 5 here, that's 0.4, but that's actually just going to be 0 since I'm doing integer division. So what do I need to do here is I need to bring this equation into the land of doubles. There's 2 ways we've learned to do that. I could do 1.0 times this, or I can typecast this like this. Either way works. I'm kind of more of a fan of the 1.0 times this. Doesn't really matter. One thing that is really important, some people will do this correction, but then put parentheses around here. This is totally the wrong thing to do, because what's the problem here is I'm still going to do the integer division first, and then I'm going to convert it into a double. So I'll do the integer division. This will be 0, and then yay, I return 0.0, which is not actually what I want. So again, careful when you're doing this. You actually want to convert success to a double before you do the division. So what was the point of all this? Well, FrogSimulation is a class, so I can't run it. But I did actually give you this fun little thing called the FrogSimulation program. And if you go ahead and run this, you'll see that, oh my gosh, here's a little pop-up. Let's run one simulation. There's my frog. Oh, he failed immediately. That's so sad. You can actually change the goal distance here, make it further away or closer. You can change the max hops. Maybe I'll give him 10 hops to try to make. And let's try to run one simulation. Wow, my frog is really bad. He's just always failing. Okay, there he goes. There he goes. Oh my gosh, he made it. It's so exciting. You can also run many simulations if you just change this number to, let's say, 10. And it'll tell you the percentage that it is successful. So in this case, 4 out of the 10 were successful. It doesn't actually show you him bouncing around when you do the run many simulations. It just tells you kind of the final answer. So there we go. There's the frog simulation problem. On your upcoming test, there will be a problem very similar to this one. And you might have been wondering this whole time, like, this feels really random. Why are we doing this? Well, one thing you didn't know is that this actually was an old AP question. And let me actually show you what that AP question looks like. If you go to a browser and you just search APCSA 2018 FRQ, and don't click on the scoring guidelines, we can click on the next one down. You can see that what actually is question 1 is this frog simulation question. Kind of cool. And look, here's the class that we worked with. It's called frog simulation. Look, there's 2 private instance variables. Oh, look, they're the exact same as my private instance variables here. And look, we're being asked to write a method called simulate and one called run simulations. And we actually did that exact thing here. I'm not going to go over and write the solution to the problem in this video because we actually already have it right here. In a separate video, though, I will actually break down how I read through a problem like this and write the solution, even though the code's exactly the same as what we wrote here, just so we can start to think about how do I actually parse through a problem that kind of has this many words in it. So, frog simulation, we can use booleans with things like for loops and while loops, and combine them to do kind of more interesting things.